Hello, and welcome to Nighttime Science, a quiet place for those who love to fall asleep, wrapped in curiosity and starlight. Tonight, we drift into the calm, luminous river that arches across our night sky. The Milky Way. Not just a galaxy, but an ancient sanctuary of time and motion. A soft spiral of stars, carrying the memories of everything that has ever shined. Imagine yourself floating slowly through a vast expanse woven from dust, light, and silence. The stars are not scattered here. They gather in gentle tides, in drifting clusters, in narrow streams that stretch like glowing threads. Across the darkness, vast clouds of gas glow faintly, as newborn suns carve hollows inside them. Elsewhere, older stars wander on quiet orbits, as though they've grown wise from circling the galaxy for billions of years. If this peaceful journey brings you ease, you're welcome to leave a like, subscribe, or share a soft thought below. It helps other sleepy travelers find their way here too, one drifting soul at a time. But for now, let the noise of the day fade. Feel your breath soften. Let your eyes grow heavier as we gently follow the hidden currents, carrying us deeper into our galactic home. Let us begin. The Milky Way stretches so widely that even a beam of light, the universe's fastest traveler, moves through it with surprising patience. Light crosses a room in a heartbeat. But to move from one end of our galaxy to the other, it would need around 100,000 years. Not centuries, not millennia, but a span of time so large that human history feels like a brief whisper in comparison. The space between stars is not empty. It is a thin ocean of drifting atoms, faint dust grains, and invisible magnetic threads that guide charged particles like gentle winds. When we gaze toward the Milky Way, we never see the present moment. We see layers of time folded into the darkness, each star shining from a different age. Some rays set out long before humans appeared on Earth. Others began their journey when the first forests grew, or when oceans were young. Every shimmer, every soft glow, is a message from the past, arriving only now to touch your eyes. Deep in the heart of this luminous structure lies something astonishing. A presence we cannot observe directly, yet one that binds the galaxy together. At the center of the Milky Way, wrapped in swirling clouds of stardust, rests a supermassive black hole. Its gravity is strong enough to bend the architecture of space itself. Stars near the core do not drift gently as ours does. They race around the center in tight, elongated loops, moving so quickly that their paths reveal the invisible mass shaping their lives. Far from the center, its pull is subtle, almost tender, guiding the galaxy's slow spiral. But close to the heart, the force becomes overwhelming, a reminder that even in the calmest corners of the night sky, there are powers beyond imagining. As we drift closer to the heart of our galaxy, vast rivers of gas begin to stretch and twist, their filaments curling inward, as though drawn toward a silent, invisible breath. These clouds fall ever deeper into the gravitational well, heating gently as they spiral, glowing softly in wavelengths our eyes cannot see, but our instruments can translate into quiet streams of color. The black hole at the center does not shout. It does not roar. Its own body emits no light at all. And yet, the space around it flickers with restless activity. Matter swirling, colliding, releasing energy as it surrenders to that immense pull. This hidden core acts as the anchor of our galaxy, the weight at the center of a spinning wheel, holding the spiral in place, and guiding the majestic rotation of hundreds of billions of stars. It is strange to picture something so powerful, and yet so silent. A presence that bends space, shapes time, and orchestrates the dance of suns, without ever revealing its form. But the Milky Way has known other giants too. Long ago, a smaller galaxy wandered too close, drifting through the darkness, until the tides of our own system pulled it apart piece by piece. Its stars were unstitched from their home, and slowly woven into ours. Its clusters stretched into luminous streams, long arcs of starlight that still encircle the Milky Way, like faded scars, or ancient constellations, remembering where they once belonged. Astronomers can still trace these ghosts through the way they move, or the subtle differences in their chemical signatures. Tiny clues revealing that they were born in a different cradle of stars. This cosmic merging likely reshaped our spiral arms, thickened the disk, and stirred the invisible halo of dark matter that surrounds us. The Milky Way you see today carries the memory of this ancient encounter. A vanished companion lives on within us, its remnants woven quietly into our celestial home. And surrounding this home is a peaceful gathering of smaller galaxies, tiny elders orbiting slowly, in vast, graceful loops. Some are so faint they seem carved from moonlight, barely distinguishable from the night around them. Their populations are sparse, their stars old, their shapes delicate. Yet their influence reaches deep into the structure of the Milky Way. As they circle us, they tug gently on the outer halo, sending subtle ripples through the dark matter envelope that surrounds everything. Many of them leave behind thin trails of stars, streams unraveling behind them, like threads pulled from an ancient tapestry. These pale arcs help scientists understand how galaxies grow, not through sudden violence alone, but through countless small interactions, spread across billions of years. Each satellite galaxy moves like an elder in a vast family, preserving stories from an earlier universe. Their motions, their orbits, their chemistry add layers of meaning to the long history of our spiral home. Even our own star is part of this great motion. We often imagine the sun as steady, a warm, unmoving anchor overhead. But in truth, it races through the galaxy at a speed that surpasses the flight of a bullet. Every planet, every moon, every cloud of dust and drifting particle rides this immense journey with it. We are passengers on a starship we cannot steer and barely feel. The sun follows a vast, curved orbit around the galactic center, guided by the combined gravity of countless stars and the mysterious pull of dark matter. Though we feel no wind from this motion, and no shift beneath our feet, this voyage has shaped our past, and will shape our distant future. As the sun travels, it passes through regions filled with thin gas, whispering radiation, and subtle gravitational currents that brush against the boundaries of our solar system. This quiet odyssey has lasted for billions of years, and will continue long after our species is gone. To think of our familiar star not as a fixed point, but as a traveler moving through the Milky Way's enormous seas, invites a sense of deep, gentle awe. Nothing here is still. Nothing here is isolated. Everything moves in rhythms too vast for a single human life to notice. And deep within the galaxy, in clouds so cold that fire cannot survive. New stars are waiting to be born. Deep within the Milky Way, in regions where starlight cannot reach, lie enormous clouds so cold that their temperatures sink far below anything Earth has ever known. These clouds appear as dark patches in the sky, not because they are empty, but because they are dense enough to hide the stars behind them. Molecules inside move slowly, almost drowsily, as if resting before the long work of creation begins. In these frozen chambers, fire cannot take hold. There is no flame, no spark, no ember. Only gravity, quiet, patient, tireless. Gravity gathers the dust and gas, drawing them inward grain by grain, forming pockets of material that grow heavier over time. As each pocket contracts under its own weight, the pressure rises, warming the core in a way no ordinary heat could compare to. There is no rush, no sudden brightness. Only an ancient rhythm of collapse that continues over thousands, sometimes millions of years. And then, after unimaginable spans of time, the center becomes hot enough for fusion to awaken. In that moment, a star is born, a sun ignited not by flame but by the silent squeeze of gravity. The thought that radiant, brilliant stars begin as frozen knots of shadow feels almost like a whispered cosmic secret. Light is often born from stillness, from places where warmth was once only a dream. Even our own solar system carries the imprint of ancient stars. Long before Earth existed, massive suns near our region of the galaxy lived fast and died violently, exploding as supernovas and hollowing out a vast bubble around us. We drift inside that bubble now, never noticing the enormous cavity of hot, thin gas that surrounds our entire solar system. The interior of this bubble is less dense than almost any other place in the galaxy. Our sun and planets wander through it gently, as though passing through a vast, quiet hall carved by long-vanished giants. Its edges form rippled walls of cooler gas, the slowed remnants of ancient shock waves. Astronomers map this bubble by watching the faint glow of the hot gas within it, tracing the ghostly contours of supernovas that died before humanity's earliest ancestors walked the Earth. To realize that our entire solar system floats inside the footprints of old stars is to feel a soft, humbling truth. We live inside the echo of cosmic history. And the Milky Way continues to reshape itself with a patience only galaxies possess. From afar, spiral galaxies look serene, delicate swirls of light gliding through the dark. But up close, they are places of interaction and hunger, where large galaxies quietly draw in smaller companions over billions of years. Our galaxy is no different. It pulls gently on the tiny galaxies that orbit around it, stretching their stars into long, pale ribbons that wrap around the Milky Way like drifting silk. These stellar streams trace the paths of smaller galaxies dissolving into our own, their shapes unraveling as gravity tugs them inward, star by star. This slow merging has happened many times before, and will continue for billions of years to come. It explains why our galaxy holds ancient clusters and unusual populations of stars, scattered throughout its halo and disk. Right now, the Sagittarius dwarf galaxy is being pulled apart, its stars blending into our own population, as its remnants spiral toward the center. The idea that our galaxy grows through countless acts of slow, quiet consumption feels both eerie and fascinating. A reminder that even objects as enormous as galaxies are shaped by gentle, relentless gravity. Among the Milky Way's inhabitants are stars older than Earth by billions of years. Some formed when the galaxy itself was young, when heavy elements were rare, and the universe had not yet lived through many cycles of star birth and death. These ancient suns contain fewer metals, their atmospheres simpler, their light carrying signatures from a time when the cosmos was still writing its earliest chapters. Many drift far above the spiral arms, moving through the galactic halo, on long, looping orbits that take them high into the quiet outskirts of the Milky Way. To observe these old stars is to look directly into the past. They burn steadily, calmly, holding the memory of an era when the galaxy was new and the universe was still learning how to make the elements of life. Some stars in the Milky Way are so ancient that they began shining long before Earth was even dust. Their soft light is a quiet reminder that our galaxy had a long and luminous life before our world ever opened its eyes. And much of that light, the faint glow that stretches across a clear night sky, comes from stars so small and so dim that no telescope can ever separate them. When you look up and see the Milky Way as a pale river drifting across the darkness, you are actually witnessing the combined breath of countless suns, too subtle to be seen on their own. These tiny stars fill the disk of the galaxy, like fine grains of sparkling sand. Dust and drifting gas scatter their light, giving the Milky Way its soft, hazy texture, a luminous mist that gently bleeds across the sky. Though individually unimpressive, these faint suns hold enormous influence. Together they contribute a significant fraction of the galaxy's mass, helping shape the gravitational field that guides the motion of brighter, more familiar stars. Some are old red dwarfs, burning slowly through trillions of years. Others are newborn suns, just beginning their long journey of fusion. The knowledge that our galaxy shines because of a quiet choir of unseen stars adds a delicate sense of wonder, as though the night sky whispers, with voices too soft for human hearing. But not everything drifting through the Milky Way belongs to a star. Scattered through the dark are planets without a sun, entire worlds wandering alone, unattached to any system. These rogue planets were once part of families, orbiting young stars before gravitational interactions threw them into exile. Now they travel through the galaxy in deep, frigid silence, without the warmth of a star. Their surfaces may be frozen solid, yet some might hide warm oceans beneath thick layers of ice, heated only by the slow cooling of their interiors. These worlds move freely, guided solely by the gravity of the Milky Way, following paths that drift across the spiral arms, dip into the halo, and slide past clusters, as though gliding through a great cosmic sea. Simulations suggest that rogue planets might even outnumber the planets that orbit stars. The thought of endless silent worlds drifting through the darkness adds a haunting kind of beauty. Entire globes traveling with no sunrise, no sunset, no orbit, just a solitary glide through the night of the galaxy. Far beyond the familiar arms of the Milky Way, another structure surrounds us, a vast halo of superheated gas, stretching far above and below the galactic disk. This halo is unimaginably hot, far hotter than any flame that could ever burn on Earth. Its particles move so energetically that the gas glows in faint X-rays, light invisible to human eyes but detectable by sensitive telescopes. Though extremely diffuse, this halo contains enough mass to tug gently on stars and satellite galaxies, influencing their motions in subtle but persistent ways. Astronomers believe this enormous sphere is a relic of the Milky Way's formation, as well as the accumulated result of countless stellar explosions that flung material outward over billions of years. It acts as a reservoir, a quiet ocean of hot gas that may one day cool, fall inward, and spark new generations of stars. Though unseen in visible light, this vast and ancient atmosphere wraps the entire galaxy like a shimmering cocoon. Far within the disk, another form of hidden light travels through space. When massive stars explode, their shock waves surge outward, energizing nearby gas and leaving behind faint echoes that can travel farther than the visible light of the explosion. These echoes come to us as radio waves, gentle in tone, yet powerful in reach. Even after the expanding cloud has faded from sight, the radio glow lingers, drifting quietly across the Milky Way for tens of thousands of years. Astronomers use these lingering whispers to trace the shapes of supernova remnants buried within dense dust clouds. Each ripple carries a record of the explosion's force, its expanding shell, and the elements it cast into space, the seeds that will one day form planets, oceans, and life. Even after a supernova has faded from sight, its memory continues to travel through the galaxy. Long, gentle waves of radio light drift outward from the ruins of the explosion, carrying with them echoes of the star's final breath. These waves reveal histories older than any human story, moments when regions of the Milky Way looked nothing like they do now, when the sky was lit by suns that no longer exist. In this soft radio glow, the galaxy shares secrets of its past. It whispers about the heavy elements that once formed inside brilliant, short-lived stars and were scattered into space when those stars died. Everything solid, the iron in your blood, the calcium in your bones, the metals within Earth's core, originated in those ancient explosions. Radio waves allow us to listen to the fading heartbeat of the stars that made us. And among the remnants of such cosmic deaths are the strangest objects known to exist. Neutron stars. Objects so dense that a teaspoon of their material would outweigh a mountain on Earth. When a massive star collapses, ordinary atoms can no longer hold their shape. Protons and electrons fuse into neutrons, creating matter so compressed that it behaves like nothing found in our world. If you could somehow scoop even a spoonful, something far beyond human possibility, you would hold a mass heavier than the tallest peaks on our planet. This density curls space, warps light, and twists magnetic fields into shapes that defy imagination. Many neutron stars spin with extraordinary speed, rotating dozens or even hundreds of times each second, sweeping beams of radiation through space like cosmic lighthouses. Others possess magnetic fields so powerful they could erase the data on Earth's devices from across the distance of the Moon. Their surfaces are smooth and flawless, because their gravity forbids even the smallest bump from rising above the crust. These stellar remnants cool slowly, releasing their stored heat over millions of years. By studying them, scientists learn about the limits of matter, what happens when nature pushes physics to its most extreme edges. Neutron stars remind us that the universe contains states of being far beyond anything we can touch or comprehend. And while these dense remnants hold their secrets, other structures drift softly across the galaxy, star streams, the delicate rivers of light left behind by long-lost companions. Spread across the Milky Way are faint chains of stars that follow graceful curves through space. They were once parts of smaller galaxies and clusters, but over billions of years, the Milky Way's gravity pulled them apart thread by thread. Their stars now drift along stretched orbits, spanning enormous distances, like pale ribbons flowing through the dark. These streams record a quiet history of encounters and mergers. By measuring their motions and mapping their shapes, astronomers can reconstruct the stories of galaxies that once circled our own. Some streams soar far above the galactic disk, arching into the halo before looping back down. Others weave gently through the spiral arms, moving almost unnoticed among younger populations of stars. Their paths trace the invisible presence of the Milky Way's dark matter halo. Because the stars follow gravity alone, their trajectories reveal where unseen mass exerts its influence. In this subtle way, star streams show us that our galaxy is not static, but continuously reshaped by encounters stretching across cosmic time. They are quiet reminders, fossil trails of ancient meetings. And while the past leaves its traces, The present is alive with creation. Throughout the Milky Way, new stars are igniting every moment. In shattered, quiet clouds scattered across the spiral arms, gravity pulls gas into dense pockets, where heat slowly builds. When temperatures finally reach the threshold for nuclear fusion, a star is born. This happens not once in a great while, but constantly, as rhythmically as breaths in a sleeping body. Every second, somewhere in the galaxy, a new sun opens its eyes to the darkness. Some of these newborn stars are tiny red dwarfs that will glow gently for trillions of years, longer than the current age of the universe itself. The smallest stars in our galaxy, the gentle red dwarfs, shine with a patience that almost feels eternal. They burn so slowly, so economically, that their light will continue long after the Milky Way itself has changed beyond recognition. Some will glow quietly for trillions of years, outliving every bright blue giant and every sun-like star we know. Others, larger and more luminous, are destined for brief brilliance. They blaze with intensity, consuming their fuel in cosmic heartbeats, their lives unfolding quickly before ending in titanic explosions that reshape the regions around them. These places where stars form, those soft nurseries of dust and gas, are sculpted not only by gravity, but by turbulence, magnetic fields, and the ancient debris left behind by earlier generations of stars. When a star is born, its newborn light pushes outward, slowly clearing the cloud that once hid it. The dust thins, and suddenly clusters emerge, delicate gatherings of young suns shining against the darker canvas. Their warm winds carve the remnants of the very nebula that created them, reshaping it into pillars, arches, and open spaces. The Milky Way breathes this rhythm constantly. As old stars fade into quiet remnants, new stars rise to replace them, ensuring the galaxy never stops evolving. Light is renewed, generation after generation, in an endless celestial cycle. Some stars spin so quickly that without their own immense gravity they would simply fly apart. Across the Milky Way there exist stellar bodies that rotate with breath-stealing speed, their equators traveling at hundreds of kilometers per second. This rapid rotation stretches them, flattening their shapes and making their poles hotter than their softly bulging middles. Fast-spinning stars often host strong magnetic fields that twist and snap, guiding streams of gas into glowing rings or thin swirling disks. Their furious motion influences how they burn their fuel, how they evolve, and the kind of death they will experience. Observing them teaches scientists the subtle boundary between stability and collapse, the precise point where a star can no longer withstand its own spinning momentum. These rapid rotators show us that even among the calm lights of the night sky, there are worlds in tension, balanced delicately between outward force and the pull of their own burning hearts. Not all regions of the Milky Way are filled with stars, dust, and gas. Some areas are astonishingly empty, vast hollows carved out by ancient cosmic events. These enormous cavities can stretch for hundreds of light years, wide enough to swallow whole constellations if they drifted near. Long ago, clusters of massive stars lived fast and died violently. Their fierce winds and explosive ends blew enormous amounts of gas away, sweeping the surrounding medium aside and leaving behind great, hollow spaces. Over millions of years these bubbles collided, fused, and widened into the immense voids we see today. Though thin and quiet, these pockets of emptiness are still shaped by the soft pressure of surrounding gas and the persistent pull of the galaxy's gravity. Their boundaries preserve clues about where star clusters once lived and how their final breaths reshaped entire regions of the Milky Way. These hollow chambers contrast beautifully with dense molecular clouds where new stars take form. They reveal a galaxy in motion, a structure sculpted by cycles of creation and destruction, birth and dissolution. Deep within this same galaxy exist worlds unlike anything on Earth, carbon-rich planets where unimaginable pressures may transform entire layers of their interiors into diamond-like crystal. These diamond worlds form in places where carbon was abundant during their birth, Unlike Earth, whose interior is shaped by silicates and metals, these exotic planets contain enough carbon that the crushing weight of their layers can forge crystalline structures buried far beneath their surfaces. Above, they may appear dark and rocky, unremarkable in the cold starlight. But below, their interiors shimmer with landscapes of diamond-like brilliance never touched by human eyes. Some orbit close to their stars, their surfaces scorched by constant heat. Others wander farther out, cold and quiet. Each carries a unique chemistry that reflects the environment of its birth. Imagining such worlds, entire planets built from the universe's hardest crystal, reminds us of how diverse and wondrous the Milky Way truly is. And then there are the stars that do not merely glow, they erupt. Some stars unleash bursts of energy so powerful they could strip atmospheres from planets, or scorch their surfaces in an instant. These eruptions occur when magnetic fields twist, tighten, and suddenly snap, releasing floods of radiation into space. These violent flares are rare but breathtaking in scale. Even from distant corners of the galaxy, they can be detected as intense flashes of high-energy particles and light. Many such stars are young, still learning to settle into stable rotation and rhythm. Others are older, but twisted by magnetic fields far stronger than our suns. These sudden outbursts remind us that stars are not simply calm lanterns floating in the night. They are dynamic, restless furnaces with tempers, cycles, and unpredictable moments of unleashed energy. Stars, for all their quiet glow, are not the serene lanterns we imagine from afar. Beneath their shimmering surfaces live forces that twist, pulse, and occasionally burst with energy powerful enough to reshape the space around them. A star can seem calm for eons, only to send out a sudden wave of light that ripples through its planetary system like a breath released too quickly. This universe we inhabit is not built from stillness, it is built from motion, and even the most ancient suns carry the memory of that motion within them. Across the Milky Way, some stars host families of planets so numerous they make our solar system feel modest and quiet. While we circle the sun with a handful of planetary companions, other stars shine at the center of vast celestial gatherings, surrounded by dozens of worlds, each one tracing its own gentle arc through starlit darkness. These abundant systems form from disks of gas and dust so wide and dense that gravity sculpts not just a few planets, but entire families. Small worlds, giant worlds, icy wanderers, rocky spheres, planets that hug their star and planets that drift on distant, frigid orbits, all sharing a birthplace, yet each growing in its own direction. Over millions of years, their orbits shift in intricate dances, creating patterns that stretch far beyond a single lifetime. Studying these systems reveals how diverse planetary architecture can become when nature has more material and more time to experiment. And in this quiet cosmic abundance, we are reminded that the Milky Way is overflowing with worlds we have not yet seen, worlds waiting patiently for our curiosity to reach them. But not every star remains where it was born. Some are pushed from home in abrupt, dramatic moments that unfold faster than thought. A close gravitational encounter within a crowded cluster, or the sudden detonation of a companion star collapsing into a supernova, can send a star flying like a stone struck from a sling. These runaway stars drift through the galaxy on long, solitary paths, moving faster than their neighbors, crossing the spiral arms as if carried by invisible winds. They shine like ordinary stars, yet their motion is a quiet confession of the chaos that shaped them. Astronomers trace their orbits to uncover the events that cast them into the galactic wilderness. Each runaway is a witness to a moment of disruption, a traveler carrying the memory of forces powerful enough to tear a star from its birthplace. They remind us that even the heavens experience moments of sudden change, and that wandering is not limited to living things. In other corners of the Milky Way, stars come together in numbers so great that their light blends into a single, luminous haze. These are stellar clusters, cradles where star birth happened not one at a time, but all at once. Huge clouds of gas collapsed, forming hundreds or thousands of stars in a single burst of creation. Because they were born together, they remained close for millions of years, drifting slowly apart only as age and gravity pull their delicate bonds loose. In these young clusters, the distance between stars can be far smaller than the space between planets in our own solar system. Their combined glow fills the region around them with a soft, internal sunrise, a light that seems to come from every direction at once. Some clusters gather into nearly perfect spheres, their stars packed densely at the core. Others form airy, sprawling associations, still shining brightly through the dust-laced currents of the galaxy. Astronomers study these stellar families because their shared age and diverse masses offer a rare glimpse into how stars evolve side by side. They are like cosmic classrooms, each star a different lesson, each cluster a quiet archive of how light begins and how it changes over time. Within stellar clusters, astronomers can watch the entire life of a star unfold as though time itself were gently slowing just long enough for us to observe. Each star inside these crowded nurseries changes in subtle, graceful ways, warming, expanding, maturing, and one day growing faint again. Clusters offer a rare window into these delicate transitions, because all their stars were born together, sharing age but not destiny. Their combined radiation flows outward in soft, powerful waves, carving hollows into the gas around them. Stellar winds sweep through the region like invisible sculptors, shaping the next generation of star-forming clouds. Creation doesn't come from stillness alone, it rises from the echoes of earlier light. These bright, bustling neighborhoods of stars remind us that much of the galaxy is born in company, not in solitude. Stars are social beings at first, born shoulder to shoulder, surrounded by siblings, glowing with shared brilliance. Across the Milky Way lie enormous molecular clouds, gigantic, shadowed realms that drift through the spiral arms like dark rivers awaiting dawn. They are frigid, silent, and seemingly empty to human eyes, yet they carry within them the raw material for thousands of future suns. These clouds are vast enough to reshape the imagination. Some stretch for hundreds of light years, woven from hydrogen molecules and ancient dust, a quiet mixture that remembers every generation of stars that lived before. Inside these clouds, gravity whispers its quiet instructions. Dense knots begin to form, slowly tightening, cradling the first faint warmth of what will become new starlight. But despite their enormity, molecular clouds can be surprisingly fragile. A single nearby supernova can send a shock wave that presses them into new shapes, triggering cascades of starbirth. A massive star's radiation can peel away their edges, evaporating darkness into shimmering curtains. To truly see these hidden cradles, astronomers use instruments that look not for visible light but for gentle radio and infrared whispers. Within their opaque folds, entire stellar clusters wait like unhatched constellations, silent, invisible, gathering brightness slowly until they are ready to shine. Among the galaxy's diverse inhabitants are stars that pulse like living hearts. Their brightness rises and falls with rhythmic certainty, as though they breathe in cycles of expansion and contraction. These pulsating stars are governed by the shifting balance between heat and pressure deep within their layers. As they swell, their glow softens as they contract, their light strengthens, a natural rhythm that can last hours, days, or months. Astronomers read these pulses like notes in a song, using their timing and their strength to understand the star's inner structure, its age, its temperature, its mass. Some of these pulsating stars follow patterns so consistent they serve as milestones across the cosmos, measuring distances, mapping spiral arms, revealing the shape of the Milky Way itself. Each flicker, each soft breath of brightness, adds gentle movement to the night sky, reminding us that even seemingly steady stars contain quiet rhythms hidden beneath their calm surface. And drifting through the galaxy are shock waves, vast, expanding ripples born from ancient supernovas. Long after the brilliant flash has faded, long after the nebula has cooled, the shock wave continues its silent travel, carrying the memory of the explosion across light years. These waves sweep through dust clouds, pressing them into new sculptures, or through emptier regions, where they weaken gently yet never fully vanish. They move outward for tens of thousands of years, changing shape, changing density, changing the future. Shock waves can spark new stars by compressing cold gas until gravity takes over again. They enrich the interstellar medium with heavy elements: iron, carbon, oxygen, calcium, the same elements that later become planets, oceans, and living beings. Modern telescopes detect these ancient ripples not with visible light but with faint X-ray glimmers and soft washes of radio waves. Through these quiet signals we hear the lingering echo of stars that lived brilliantly and died with force, their final breaths still traveling through the Milky Way like long, slow waves breaking on the shore of time. Even long after a dying star has vanished into silence, its final breath continues moving outward, a faint, expanding shell of energy that drifts through the Milky Way like a slowly widening memory. These ancient shock fronts stretch into delicate filaments, revealing the hidden contours of the space they pass through. The star itself may be gone, but the imprint of its final moment continues to ripple gently across the galaxy, nudging clouds of gas, stirring dust, whispering to the places where future stars will one day awaken. The dust that floats through the Milky Way has origins as dramatic as any cosmic story ever told. Much of it was forged in the quiet fading years of ancient suns. When these stars swelled into red giants, their outer layers cooled just enough for tiny grains of solid matter to appear, microscopic seeds of carbon, silicon, and oxygen. As these aged stars exhaled their outer layers into surrounding space, they released clouds of dust that drifted into the galaxy's arms like soft, dark pollen. Other dust grains were born from the fierce endings of massive stars, supernovas that scattered newly forged elements across light years in a single, powerful exhalation. Over millions of years, these particles traveled through the galaxy, settling into nebulae, cooling collapsing clouds, shielding fragile molecules from harsh starlight, and offering surfaces on which the chemistry of life could begin. Dust shapes the soft glow of the Milky Way, absorbing light, scattering it, painting the galaxy with gentle shadows. Every grain carries the memory of the star that created it. Some of those grains eventually help form Earth, its mountains, its oceans, its living cells. To realize that the dust beneath our feet once drifted through space as the final breath of ancient suns creates a quiet sense of belonging to the wider cycles of cosmic life. Near the center of the Milky Way, gravity becomes so intense that only the fastest stars can hold their course. A handful of them orbit the galactic core with astonishing speeds, whirling so quickly that their paths must be tracked for years to reveal their intricate loops. Their existence is profound evidence of the supermassive black hole hidden behind clouds of dust at the galaxy's heart. As these stars sweep close to it, their orbits curve sharply, a dance governed by gravity strong enough to warp the very fabric of space. Even in this turbulent environment filled with dense gas, twisting magnetic fields, and radiation storms, these stars remain steady, their light unwavering as they trace their elegant, dangerous circuits. To observe them, astronomers must use infrared vision to pierce the dusty veil around the core. Each orbit, each shift, reveals a little more about this mysterious region, a place where space bends softly beneath unimaginable forces. Across the Milky Way, gravity does more than guide motion, it shapes light itself. When starlight passes near regions dense with mass, clusters of stars, hidden clouds of dark matter, or heavy streams of gas, its path bends subtly, stretching or magnifying the shapes of distant objects behind it. This phenomenon, called gravitational lensing, turns gravity into a quiet sculptor of light. Through these distortions, astronomers can detect worlds that emit no visible glow, free-floating planets, faint stars, black holes wandering alone. Lensing also reveals how much of the galaxy is made of ordinary matter, and how much exists as invisible mass, dark matter that exerts gravity yet gives off no light. Every time we look at the sky, the starlight we see has traveled through this shifting landscape, bent by gravity, shaped by invisible structures, carrying with it a subtle signature of the galaxy's hidden architecture. It reminds us that even the quiet glimmer of a star overhead is the result of a long journey through a universe far more intricate than it first appears. All throughout the Milky Way, high-energy particles dash through space at speeds approaching that of light. These cosmic rays, born from supernovas, restless magnetic fields, and energetic stars, sweep across the galaxy in a constant, invisible rain. Even though Earth is shielded by its magnetic field and protective atmosphere, some particles still arrive here every moment, colliding gently with the upper air and creating delicate showers of secondary particles that melt away long before reaching the ground. By studying cosmic rays, scientists can track some of the most violent events in the galaxy: the explosions that seeded space with elements, the magnetic storms that twist through spiral arms, the processes that energize particles to astonishing speeds. Cosmic rays remind us that Earth is not isolated, not separate from the galaxy. We are immersed in the Milky Way's quiet activity, connected to its storms, its ancient explosions, its invisible energies that drift across the darkness. Even here, beneath the familiar calm of our night sky, the Milky Way continues to breathe, sending out particles, signals, and quiet forces that brush gently against our small blue world. Cosmic rays, drifting magnetism, the faint energy of distant suns, all of it arrives in subtle, constant waves. A reminder that our home is part of a living galaxy full of motion and invisible communication. Some stars burn with such intensity that their light reshapes everything orbiting too close to them. These are young suns, or massive suns, stars whose surfaces churn with ultraviolet fire and winds of charged particles that rush outward like invisible storms. When a small planet ventures too near, its atmosphere begins to tremble. The upper layers heat, rise, and slowly drift away into space, not in an instant, but in a long, delicate escape that may continue for millions of years. A world that once held oceans and clouds can gradually lose its sky, its air thinning until only rock remains. This slow erosion reveals how deeply a star shapes the destiny of its planets. A world's habitability, its ability to hold warmth, water, or even life, depends on a delicate balance between the heat it receives, the protection its magnetic field provides, and the strength of its own atmosphere. To imagine a world being quietly unmade by the very star that warms it is to understand the profound power that radiance alone can hold. Deeper within the Milky Way lie strange, magnetic titans that defy intuition. The magnetars. These compact stars, remnants of once massive suns, are no larger than a city, yet hold magnetic fields so overwhelmingly strong that they can distort atoms, warp nearby space, and influence particles from thousands of kilometers away. Occasionally, these magnetic giants shift or crack in their crust, and when they do, they release bursts of energy that can briefly outshine entire star clusters. A momentary flash, the galaxy illuminated by a pinpoint of unimaginable power. Magnetars rotate slowly, their motion deliberate and heavy, as though weighted by the very fields they command. They sit among the most extreme objects known, bridging the world of gravity and nuclear physics with forces we can scarcely imagine. Their existence reminds us that the Milky Way contains not only beauty and calm, but exotic wonders, rare creations born from collapse and fire, shaped by pressures found nowhere else in nature. And then, there are worlds where nightfall is marked by two suns instead of one. Across the galaxy, planets orbit binary stars, twin lights bound together in a quiet gravitational dance. Some planets circle both stars at once, their path wide and smooth, as though they revolve around a single blended glow. Others move in more elaborate patterns, passing between the two suns, weaving an orbit that changes with every loop. Imagine the sky of such a world, two dawns unfolding together, two sunsets washing the horizon with overlapping colors. Sometimes one sun would rise just as the other sinks, painting the surface in shifting, unpredictable warmth. The climates on these worlds are unlike anything Earth has ever known. Subtle variations in light, tides influenced by multiple gravitational pulls, days that stretch or shimmer beneath the rhythm of twin fires. These systems demonstrate how adaptable the universe can be. Even when two suns pull at the surrounding disk, planets still form, still settle into stable orbits, still find a place to exist. To picture a world lit by twin stars is to feel the quiet creativity of nature, a reminder that the Milky Way holds arrangements and possibilities far richer than the simple patterns we once assumed were universal. Near the heart of the Milky Way, in the region where gravity folds space like soft cloth and radiation hums in colors we cannot see, there are traces of something almost impossible. Clouds made not of familiar matter, but of its rare and fragile opposite. Here, suspended like faint whispers between turbulent stars and magnetic storms, lie thin pockets of antimatter, the mirror twin of everything we know. These clouds are not bright, nor do they gather into shapes like gas or dust. Instead, they reveal themselves only in the moments when particles and antiparticles touch and vanish into bursts of light. The origins of these ghost-like reservoirs remain one of the galaxy's quiet riddles. Perhaps they are born from the violent breath of massive stars burning out their lives. Perhaps they originate from the restless activity near the central black hole, where jets of charged particles slice through surrounding gas with unimaginable force. Or perhaps they emerge from dense knots of matter pressed together in ways Earth can never reproduce. To search for antimatter is to probe a realm of physics that seems almost mythic, a place where particles carry the possibility of absolute annihilation, yet drift peacefully through the crowded center of our galaxy. Even faint as they are, these traces reveal an important truth. The core of the Milky Way is anything but still. It is a cauldron of extremes, of energy, gravity, radiation, and mystery, a place where the universe keeps some of its most extraordinary secrets. Far from the brightness of the central bulge, across the quieter outskirts of the galaxy, another kind of story stretches out in silence. Delicate, ribbon-like streams of stars wander through space like the long, fading memories of galaxies the Milky Way once consumed. Long ago, far before Earth existed, far before the Sun was born, smaller galaxies drifted too near our own. Their shapes stretched, thinned, and slowly unraveled under the persistent pull of the Milky Way's gravity. What remains now are long rivers of starlight moving through darkness, carrying the last echoes of the worlds we absorbed. These stellar threads curve far above the spiral arms and weave quietly through the disk. By tracing their motions, astronomers can reconstruct the ancient migrations and collisions that shaped our galactic home. And because their paths bend in response to the unseen mass around them, these streams map the invisible skeleton of dark matter that surrounds the Milky Way. Each drifting star is a relic of a lost galaxy, a reminder that our home is built from countless older homes now melted into one. Deeper within the galaxy, stars are often born in pairs, bound together in long, elegant orbits that can last billions of years. Their dance is slow and profound, a gravitational embrace sustained through eons. But not all dances last forever. As ages pass, some binary stars drift closer. Their orbits tighten as they exchange energy through tides and stellar winds. Quietly, slowly, almost imperceptibly, they spiral inward until one day their surfaces touch, and they merge. The collision of two stars is a breathtaking event. A sudden bloom of light, a luminous red nova that outshines entire clusters before fading gently back into dark. In that moment, heavy elements are forged and released, enriching the galaxy with the ingredients for planets, for life, for future suns. Binary mergers are rare, dramatic, and deeply poetic. Two ancient lights falling toward one another until they become one flame. Even in the quiet night sky, such unions unfold unseen, subtle reminders of the slow choreography woven into the Milky Way. Beyond these stellar dramas, the galaxy hosts worlds whose weather belongs more to dream than to science as we know it. On some scorching exoplanets, temperatures rise so fiercely that metals themselves evaporate into shimmering vapor. And when the high-altitude winds cool, the vapor condenses, falling as rain not of water, but of molten iron descending in glowing droplets. On other worlds, the atmosphere becomes a storm of glass. Silicate particles, heated to incandescence, melt and rise into the sky before descending again as razor-edged shards driven sideways by winds faster than hurricanes. Imagine standing beneath a storm of molten glass, a world where the sky itself glows, where every gust is a river of liquid rock. These exotic climates arise on planets that orbit close to their stars, or on worlds whose chemical makeup is wildly different from our own. Their surfaces shift and boil, their skies shimmer with metals and clouds of mineral vapor. To observe such worlds is to expand the boundaries of what weather can mean. It is to understand that the Milky Way does not merely host variants of Earth but worlds sculpted by forces we have barely begun to imagine. The farther we look into the galaxy, the more we discover worlds sculpted by forces that feel almost mythic. Some planets shimmer beneath storms of metal and glass, their skies shaped by temperatures so fierce that even rock becomes a wandering vapor. Droplets of molten iron fall like glowing rain. Silicate dust melts into liquid shards that race across their horizons in sideways storms of blazing glass. These landscapes are not gentle, but they are beautiful in a way that belongs only to alien worlds, sculpted by heat, shaped by chemistry, dancing to rhythms Earth has never known. Across the Milky Way, ancient cycles of birth and destruction have hollowed out enormous chambers in the interstellar medium. Every time a massive star dies, it ends its life in an explosion that sends shock waves rolling outward like rings in water. When generations of such stars live and die in the same neighborhood, their combined forces push away gas and dust until a vast cavern forms, a bubble of hot, thin, echoing space outlined by walls of cooler materials swept together over millions of years. These cosmic cavities hold the memories of entire eras of star formation. A cluster forms, lives fast, burns fiercely, and then ends in fire. Each explosion reshapes the region, dictating where the next generation of stars will emerge. To trace these hollowed regions is to watch the Milky Way breathe, inhaling matter into new suns, exhaling energy through supernova winds, each cycle etched into the galaxy like a quiet record of creation and collapse. Not every star remains where it first ignited. Some are flung so violently that they escape their galaxies entirely. A close encounter with a black hole, a brush with a crowded cluster, or the sudden disappearance of a companion star in a supernova can send a star hurtling outward with enough speed to break free of the Milky Way's gravity. Once expelled, it becomes a wanderer, a lone spark moving through the dark between galaxies, where distances stretch into quiet infinity. These exiled stars carry no planetary system with them, no familiar neighbors, no guiding spiral arm. They drift through intergalactic night in silence, their journey shaped only by the faint pull of distant masses. The Milky Way has released many such stars over its lifetime, quiet refugees of violent events, travelers crossing places few objects ever reach. Their existence reminds us that galaxies are not perfect islands. They interact, collide, shed matter, and remake themselves over billions of years. Scattered far beyond the bright disk of the galaxy lie clusters that predate everything we know. These ancient globular clusters are tightly packed spheres of stars, so dense that if you stood on a planet within one, the sky would glow with hundreds of suns even at midnight. They formed when the Milky Way itself was still young, before spiral arms unfurled and long before Earth existed. Their stars contain few heavy elements, a sign of their ancient origin, created at a time when the cosmos had not yet been enriched by generations of supernovas. These clusters orbit in long loops through the galactic halo, drifting far above and below the disk. They have survived collisions, mergers, and the constant pull of time, silent elders holding the memory of a universe that looked nothing like the one we see today. To observe them is to look backward into the earliest chapters of our galaxy's story. Deep within the Milky Way, among neutron stars and remnants of ancient suns, some stellar survivors pulse with perfect regularity. These are pulsars, cosmic lighthouses whose beams sweep across the galaxy as they spin. Each pulse arrives with such precision that it could be used as a clock. Born from the collapse of massive stars, pulsars rotate at astonishing speeds, sometimes dozens, sometimes hundreds of times per second. Their magnetic fields are so intense that they channel radiation into narrow beams that flare outward like the turning blink of a distant lantern. By listening to these pulses, astronomers measure distances, trace structures in the Milky Way, and study gravity in its most extreme forms. When two pulsars orbit each other, their dance sends out ripples in space-time, gravitational waves that stretch the very fabric of the universe. Pulsars bring rhythm to the galaxy's silence, steady and ancient, helping us map what cannot be seen with light alone. Across the Milky Way, certain stretches of space emit a ghost-like glow, a faint radiation left behind by events so ancient and powerful that their sources have already faded from sight. These silent regions whisper of cataclysms long extinguished. The collapse of massive stars, the flash of gamma-ray bursts, the stirring of turbulent clouds struck by high-energy particles. What remains now is only the residue of those moments, a persistent shimmer visible not to human eyes, but to instruments tuned to X-rays, gamma rays, and the subtle hum of ionized gas. When astronomers observe these zones, they are not looking at the present. They are peering into memories, imprints left in space itself. Electrons spiraling through magnetic fields, clouds heated until they radiate, and faint shells of ancient explosions all contribute to this cosmic afterglow. These regions remind us that nothing in the galaxy fully disappears. The echoes of violence remain, traveling quietly for millions of years, telling stories of forces that once shook entire sections of the Milky Way. Near the galactic center, the calm illusion of the night sky gives way to motion so fierce it almost defies imagination. Clouds of gas whirl around the central black hole with speeds that reshape the meaning of movement. Some clouds race along elongated orbits at hundreds of kilometers each second, twisting into ribbons of turbulence as they plunge through regions dense with radiation and magnetic storms. Dust hides this restless ballet from human eyes, so scientists listen in infrared and radio light, the only wavelengths capable of slipping through the thick curtains of the core. What they find is breathtaking. Gas flowing like liquid fire, colliding, stretching, spiraling toward and away from an invisible center whose gravity governs every motion. By watching these clouds dance, astronomers can weigh the unseen object at the heart of the galaxy. Each orbit becomes a clue, each twist, a measurement, each burst of motion, a whisper from the black hole that shapes the destiny of millions of stars. Deep within the galactic heart, nothing is still. Elsewhere in the Milky Way, there are planets whose years last not months, not even days, but mere minutes. These worlds cling so tightly to the blazing faces of their stars that they whip around them with impossible speed, completing entire orbits in the time it takes a human to boil water or close their eyes and rest. The side that faces the star is seared by unbroken daylight, heated to extremes that strip away atmosphere and vaporize any trace of oceans. The far side lies in eternal shadow, cold and still, a world divided not by terrain but by light itself. Over time, many of these planets lose layers of themselves, their atmospheres shredded by radiation, their surfaces reshaped by tides pulled tight by gravity. Their strange rhythm of day and night, their blistering proximity to their stars, and their rapid motion challenge our intuitions about what a planet can be. They reveal the flexibility of cosmic architecture, a universe that builds worlds far stranger than the quiet orbit of Earth. And deep within the galaxy, far from the familiar comforts of mountains, continents, and gentle oceans, there exist worlds made almost entirely of water. Not water as we know it. Not lakes, not seas, but vast global oceans layered in exotic forms, ice hardened by unimaginable pressure, liquids thicker than any found on Earth, and strange crystalline phases that exist only at the edge between crushing weight and intense heat. These water-rich planets are often larger than Earth, with gravity strong enough to hold thousands of kilometers of ocean above buried rocky cores. Wrapped in thick atmospheres, their deep layers are warmed until water becomes something both familiar and alien, a fluid that behaves differently from anything our world can produce. Such planets expand the definition of what a habitable world might be. They hint at oceans without shores, skies without land, worlds where life, if it exists, would rise and fall in endless blue twilight. They remind us that the Milky Way is not limited to the patterns we see on Earth. It is an artist painting with pressure, heat, and chemistry, crafting oceans, storms, and atmospheres and forms that challenge the limits of imagination. Even the idea of a planet shaped almost entirely by water, not oceans beside continents, but worlds where the horizon is nothing but endless blue, brings a quiet widening of the imagination. Such places remind us that the Milky Way's creativity is far richer than the narrow samples we have observed here on Earth. They whisper that nature does not work from a single pattern. Instead, it plays with forms, with chemistry, with gravity, building worlds that drift far beyond anything our senses were prepared to expect. And as we drift deeper into the galaxy, we encounter stars so gentle in their glow that they could almost be mistaken for planets. These are the ultra-cool dwarfs, embers of the stellar world, burning just enough hydrogen to remain stars, yet shining so softly that their light slips mostly into the infrared, hidden from the naked eye. Their atmospheres are cool enough for molecules to weave delicate absorption patterns, turning their light into something textured and complex. From afar, they appear muted, a faint pulse in the cosmic dark, but up close, they reveal subtle chemistry and a slow, steadfast radiance that can last longer than many brighter suns. Around some of these quiet stars, planets trace gentle orbits, bathed in reddish twilight rather than blinding glare. Life there, if it ever took root, would grow in a dim, warm world where daylight feels more like the glow of embers than the blaze of a rising sun. They remind us that starlight itself comes in many forms, from violent blue-white furnaces to small, tender suns hovering just above the threshold that separates star from planet. Threaded across the Milky Way, there are structures so vast that they resemble strokes of paint brushed across the canvas of space. These are the giant arcs of interstellar gas, immense, curved shapes sculpted over millions of years by the breath of dying stars, the pressure of magnetic fields, and the gentle push of drifting clouds sliding past one another. Some arcs outline the faded boundaries of ancient cavities blown open by long-vanished supernovas. Others trace the wandering paths of massive stars that glide through the galaxy, leaving impressions in the surrounding medium like ships carving wakes through water. To human eyes, these forms remain invisible, too faint and too cold to detect. But radio and infrared observatories reveal their quiet signatures, elegant curves stretching across distances so large they dissolve ordinary understanding. They are, in their own way, evidence of the Milky Way's long memory. Every arc is a record of explosions, of winds, of gravity tugging at drifting clouds. Taken together, they give the galaxy an unexpected artistry, a vast mural shaped not by a single hand, but by millions of years of cosmic motion. Among the stars, there are groups that move together as if they never forgot the place where they were born. These drifting clusters, stellar families set loose into the galaxy, begin as dense gatherings inside the same cloud of gas. As time passes, gravity from passing stars and clouds slowly stretches the group apart. Yet even as they disperse, they continue traveling in the same direction, their motions harmonized like notes from an ancient song. For hundreds of millions of years, these stellar caravans cross the galaxy together, carrying with them the chemical signatures and shared ages that betray their common origin. Some moving groups eventually dissolve fully into the background of the Milky Way, their shared journey ending quietly as they blend into the larger stellar population. Others remain recognizable much longer, thin, graceful streams of stars continuing their migration across the spiral arms. Their gentle passage adds continuity to the ever-changing galaxy. They remind us that even stars, those bright, distant points of light, carry memories, drifting through the darkness with the imprint of their beginnings still written into the way they move. Somewhere in the vast dark folds of the Milky Way, there are stars that do not simply shine. They breathe energy into space, sending thin, luminous threads outward as if the universe itself were exhaling. These narrow beams, launched from the edges of spinning disks of gas, form when matter spirals toward a dense, hungry heart, a young star finding its shape, or a collapsed remnant gathering material into a tight embrace. As the gas falls inward, the magnetic fields twist like coiled ribbons, funneling the infalling energy into sharp, focused jets that leap into the surrounding darkness. Some of these jets stretch for light years, quietly illuminating the gas they pass through, drawing faint paths through the interstellar medium, paths that trace the history of how a star began or how an ancient object continues its silent work. Around newborn stars, these jets act like gentle sculptors, clearing away the dust of their birth and carving openings in the clouds where light can finally escape. Around denser, older stellar remnants, the jets become fierce and radiant, sending signals that can be detected across the galaxy. They remind us that even the smallest systems, a single forming star wrapped in a cocoon of dust, can create structures that reach far beyond anything we might expect. In the quiet night sky, these beams of energy stand as delicate threads woven into the fabric of the Milky Way's story. While some stars shape their surroundings with gentle streams, others move with such unbelievable speed that they are destined to leave the Milky Way forever. These hypervelocity stars, launched by powerful gravitational events, travel so quickly that not even our galaxy's vast halo will hold them for long. Some are flung outward after straying too close to the supermassive black hole in the center, a single, decisive encounter sending them hurtling into the dark like glowing embers from a distant fire. Others are released when their binary companion explodes, the balance of forces breaking in an instant, allowing one star to escape. Once set loose, these fugitives follow long, solitary paths that lead them into intergalactic space. They shine with the calm light of ordinary suns, yet their motion carries the memory of the extraordinary moments that launched them. Over billions of years, they drift into the vast quiet between galaxies, each one a wandering storyteller carrying the imprint of a cosmic event no longer visible. Not all clouds in the Milky Way are cold and still. Some are alive with electric character, vast regions of plasma, where charged particles swirl, guided by the ghost-like tension of magnetic fields. These plasma clouds twist into threads, ripple like curtains in a slow underwater current, or glow with soft, ethereal tones, as electrons spiral around magnetic lines. Often they are born from the explosive outbreaths of massive stars, or from the turbulence stirred between nebulae. Though they may appear shapeless, they trace the invisible magnetic skeleton of the galaxy, a structure we cannot see, yet one that influences everything. Plasma regions also steer cosmic rays, guiding or deflecting them, like quiet shepherds in the dark. Their presence reveals that the space between stars is not an empty void, but a landscape filled with subtle energy, shaped by fields and forces that operate far beyond human intuition. And then, as if the Milky Way wished to balance darkness with beauty, the galaxy blooms with nebulae, vast, glowing clouds, set alight by the fierce radiance of newborn stars. These young suns release ultraviolet light that energizes nearby gas, painting the sky with gentle reds, soft greens, and faint blues. Hydrogen sighs into crimson. Oxygen glimmers in turquoise. Every color reveals a different ingredient in the quiet chemistry of space. Inside these nebulae, dense pockets collapse, giving rise to the next generation of stars. Stellar winds carve pillars, hollow out caverns, and sculpt arches that look almost like artwork laid across the cosmos. These glowing regions are living laboratories, places where stars take their first breaths, shaping the clouds that nurtured them. They remind us that star birth is not only powerful, but profoundly beautiful. Between the brightness of stars and the silence of planets, there exists another kind of object, one that never fully became either. Brown dwarfs inhabit this quiet middle ground. They form from collapsing clouds of gas, just as stars do. But they never gather enough mass to ignite full fusion in their cores. Without that sustaining fire, they glow softly, radiating only the leftover warmth of their formation. Most of their light slips into the infrared, a gentle whisper rather than a shout. Their atmospheres host unusual molecules, shaped by cool temperatures and high pressure. Some brown dwarfs show flickering weather patterns, their cloud layers shifting and swirling over mere hours or days. Though dim, they populate the galaxy in great numbers, drifting quietly between brighter stars. Like forgotten lanterns glowing in the dusk, they remind us that the Milky Way is richer and more intricate than it appears, filled not only with blazing suns and orbiting worlds, but with hidden objects that lie in the spaces between, softening the darkness with their subtle, steady warmth. Some objects in our galaxy shine with a faint, hesitant glow, a reminder that not every world or star fits neatly into the categories we know. Some of them stretch the imagination so far that they feel almost like dreams placed among the stars. Far from Earth, there exist planets so close to their suns that their very surfaces surrender to heat. Rock softens, crust dissolves, and entire landscapes melt into oceans of liquid fire. On these worlds, the ground does not sit still. It moves slowly, like thick glowing rivers, sliding beneath a sky filled with strange, shimmering vapors. The radiant heat is so intense that minerals we know as solid stone rise into the air as vapor, drifting upward to form mineral clouds. And when these clouds cool, they fall again as droplets of metal or stone, returning to the restless lava below. Some of these planets are also caught in constant gravitational stretching, their interiors massaged by tidal forces that heat them from within. As a result, volcanic fountains erupt endlessly, feeding oceans of molten light that renew themselves again and again. These worlds show us that nature does not limit itself to familiar forms. It builds planets from heat, from pressure, from motion so extreme that the surface becomes a swirling canvas of red, orange, and gold. They remind us that the Milky Way holds places shaped not by calmness, but by relentless, beautiful intensity. Elsewhere in the galaxy, a very different kind of rhythm unfolds. A rhythm so precise that even the most advanced instruments on Earth struggle to match it. These are the pulsars, spinning remnants of massive stars that collapsed into astonishing density. What remains after such a collapse is a body no larger than a city. Yet it rotates with such determination that each turn sends a beam of radiation, sweeping across space, like the ticking of a cosmic clock. When that beam crosses Earth, we see a pulse. Steady, predictable, almost hypnotic. Some pulsars maintain such accuracy that their timing rivals the stability of atomic clocks built by human hands. With each pulse, astronomers can trace subtle shifts in gravity, nearby objects passing in silence, or ripples in space-time itself. Their rotation is a memory of the star that once existed. As the giant collapsed, its shrinking form spun faster and faster, just as a dancer turns more quickly when pulling in their arms. Even though pulsars eventually slow, their early lives can feature hundreds of spins in a single heartbeat. Their magnetic fields are fierce, guiding charged particles into narrow beams that flash across the universe with astonishing clarity. These strange stars become laboratories of nature, places where matter is compressed to densities no planet could survive, where physics stretches toward its limits, toward the center of the Milky Way. Another story unfolds. One hidden inside dense clouds that circle the heart of our galaxy. Deep within this region lies a vast reservoir of molecular gas. Cold, massive, and rich with the ingredients of creation. But this environment is anything but peaceful. The central region is a storm of radiation, turbulence, and gravity so powerful that entire clouds are pulled, stretched, and kneaded as they pass by. And yet, some pockets remain shielded enough to preserve fragile molecules. Within these pockets, stars begin their long, quiet journeys toward birth. Huge clusters rise from the shadows, forming some of the most active stellar nurseries found anywhere in the Milky Way. To see these hidden regions, astronomers must look through the dust, using radio and infrared eyes. Behind the opaque curtains of gas lie the blueprints of future star systems, materials shaped by the intense forces that rule the galaxy's center. These quiet reservoirs prove that even the most chaotic environments can nurture new light. Creation persists, even where gravity roars the loudest. And in the midst of all these extraordinary structures, there are worlds that share their paths, not with a star, but with another world. Across the Milky Way, rare pairs of planets exist that orbit one another while journeying together around their sun. Instead of one dominating the other, both move around a shared center, like two dancers joined at the hands, gliding through space in a slow, graceful waltz. This shared orbit shapes everything: their tides, their day lengths, their orientation toward their star. From afar, such systems can appear to be a single world, their dual nature hidden, until a careful eye notices small, delicate variations in their motion. These planetary pairs remind us that the galaxy's architecture is not limited to the patterns we know. It can be cooperative, balanced, unexpectedly elegant. To imagine two worlds bound together in cosmic partnership, moving as one across the dark, adds a soft sense of harmony to the vastness of the Milky Way. Some stars in our galaxy do not keep the familiar roundness that we instinctively imagine when we think of starlight. Instead, they spin with such breathtaking speed that the force of their rotation reshapes them. Their equators stretch outward as if pulled gently by invisible hands, while their poles remain pressed inward, creating forms that resemble softly flattened spheres. Because of this distortion, their surfaces do not glow evenly. The poles gather heat more tightly, blazing with sharper brightness, while the equator settles into cooler shades. This quiet difference in light and temperature reveals that rotation can sculpt a star as easily as wind shapes dunes on Earth. These rapidly spinning suns are often young, still carrying the momentum of their birth, still turning with the restless energy of clouds collapsing into fire. Inside them, rotation helps stir the layers of stellar material, mixing their interiors like a cosmic spoon swirling molten light. This mixing influences everything: how the star burns its fuel, how long it will live, and how it will leave the stage when its time arrives. They remind us that even familiar stars have hidden personalities, shaped not only by gravity and heat, but by motion itself. Rotation becomes another form of expression, another way the galaxy writes diversity into its endless sky. Across the Milky Way, the echoes of ancient explosions still glow with fierce, lingering fire. When a massive star ends its life in a supernova, it leaves behind a cloud of swirling debris, a luminous shroud expanding slowly through space. Even thousands of years after the blast has faded, the remnant continues to shimmer, lit by shock waves heating the surrounding gas to extraordinary temperatures. These glowing filaments and tangled knots tell the story of the star that once lived there. They reveal how violently it ended, what elements it forged in its final heartbeat, and how those elements now drift outward to become part of future planets, future stars, future worlds. Over time, the remnant spreads and cools, its edges softening as it blends into the galaxy around it. But in its bright youth, it stands as one of the most magnificent sights in the night, a reminder that endings in the cosmos can be just as beautiful and just as meaningful as beginnings. Some planets live so close to their stars that heat becomes their defining feature. On these worlds, the daylight side glows with a deep red warmth, as though the entire surface has absorbed the breath of the star itself. Atmospheres swell and shimmer, their clouds tinted gold or bronze, dancing under relentless radiation. Minerals melt into vapor, metals rise into the air. Exotic chemistry fills the skies with colors and particles that could never form on Earth. Stellar winds tear at these atmospheres, pulling long trails of glowing gas behind the planets. Like softly burning comets, their orbits are fast, sometimes lasting only a few days. Yet their capacity to endure such heat reveals a resilience shaped by cosmic extremes. These blazing worlds show us that the Milky Way does not limit itself to gentle environments. It creates planets forged by fire, made beautiful by their own adversity. Far away from these bright, hot regions lie places of profound coldness, where light barely reaches, and temperatures fall low enough for molecules to settle into crystalline sleep. In these sheltered corners, clouds of gas become cold enough for delicate ice to form. On the surfaces of tiny dust grains, water, carbon dioxide, methane, all freeze into fragile coatings, turning particles into shimmering seeds, from which more complex molecules can grow. These icy grains drift silently through darkness, waiting patiently in the cold, as chemistry unfolds at a slow, ancient rhythm. They are the quiet alchemists of the galaxy, building ingredients that may one day take part in forming planets, or life itself. Infrared eyes reveal their presence through faint and intricate absorption patterns, signatures of frozen beauty, hidden inside shadows. These frozen clouds show us that the Milky Way's cold places are not empty. They are nurseries where complexity begins, long before a star ever shines. And woven throughout the galaxy are the red giants, the elderly stars nearing the ends of their long lives. As they exhaust the hydrogen within their cores, their outer layers swell outward until they become vast, luminous spheres that glow with warm, gentle light. Inside these expanded envelopes, new elements are forged: carbon, nitrogen, oxygen, and the many heavier atoms that will one day become rock and soil, water and atmosphere, mountains and oceans. When red giants shed their outer layers, they return these elements to space, a quiet offering to the future. This enriched material drifts outward to join clouds of gas and dust that will form the next generation of stars and planets. In this way, red giants become teachers of renewal, showing that even as a star grows old, it continues to give life to the galaxy. Their gentle glow their slow shedding of stardust adds depth to the Milky Way. A reminder that the cosmos evolves, not only through fire and collapse, but through a long, peaceful generosity. The gentle winds that flow from aging red giants carry more than warmth into the darkness. They spread carbon, nitrogen, and the quiet ashes of countless reactions into the open sea of interstellar space. These drifting elements become part of nebulae, part of future clouds, part of the raw material from which new systems will rise. Watching red giants is like witnessing the galaxy breathe, exhaling matter that will one day shine again. Their soft, steady glow becomes a symbol of continuity, reminding us that renewal is not rare in the cosmos. It is woven into every phase of a star's life, especially the final ones, where endings blur seamlessly into beginnings. Not every star remains close to the place where it first ignited. Some follow long, stretched paths that sweep across enormous portions of the Milky Way. These stars journey far beyond the familiar neighborhoods where starlight crowds together, traveling into regions with thin gas, intense radiation, or quiet emptiness. Their wide, looping orbits often reflect ancient origins, stars born in smaller galaxies that the Milky Way absorbed long before Earth existed. As those little galaxies dissolved, their stars slipped into wandering trajectories that now carry them from one side of the Milky Way to the other. Others were thrown onto eccentric paths after close encounters with massive clusters or hidden concentrations of dark matter. Each time they rise above the galactic plane and fall back through its glowing spiral arms, they act as messengers, tracing the Milky Way's gravitational shape, revealing how mass is arranged from the bright disk to the invisible halo. Their slow, ancient orbits whisper that the galaxy is not a still canvas, but a living, dynamic structure shaped by countless mergers and movements over billions of years. Far beyond the crowded stars of the disk lies the galactic halo, an immense sphere surrounding everything we know. Here, faint and ancient stars drift in silence, moving with unhurried grace through regions untouched by the turbulence of star birth. Many of these halo stars formed in an era when the Milky Way itself was still taking shape, when heavy elements were rare and the universe glowed with younger light. Others are remnants of long-vanished galaxies that were absorbed and stretched into the halo's emptiness. They shine weakly, their light softened by age and distance, but they hold within them the chemical memories of a time when the cosmos was very different. Though separated by vast stretches of space, they create a quiet framework around the bright spiral arms, a reminder of the galaxy's first chapters, still drifting gently through the dark long after everything else has evolved and changed. In some binary star systems, a planet finds itself held in perfect balance between two suns. Neither star dominates, neither fades entirely from view. Instead, the world beneath them is bathed in an everlasting twilight, a gentle, dusky glow that softens shadows and blurs the line between day and night. On such planets, darkness rarely arrives. The sky shifts in subtle gradients as each star moves along its orbit, creating an endless interplay of light that never quite becomes bright, never quite becomes dim. Temperatures can range from cool to warm, depending on the star's brightness and distance, and some of these twilight worlds may even hold conditions gentle enough for oceans or life. The gravitational pull of two suns creates a dance more complex than anything in our solar system, yet these orbits can remain stable for millions, even billions, of years. They reveal that sunlight does not always come from one direction, and that the galaxy's imagination is far broader than our own. Deep within the Milky Way lie the cold, shadowed regions where new stars begin. These stellar nurseries contain vast amounts of hydrogen gas, dark, quiet, and dense enough to gather under the pull of gravity. Instead of forming single stars, these nurseries often give rise to entire families at once. As the clouds contract, they break into many smaller pockets. Each pocket collapses into a newborn star, until clusters of glowing suns emerge from the same ancient cloud. Within these clusters, massive young stars ignite quickly, their bright blue light carving out hollows and sculpting pillars of gas with powerful winds and radiation. The smaller stars, the red dwarfs, the quiet burners, linger nearby, shaped by the environment their larger siblings transform. Together, these newly born communities fill the galaxy with fresh starlight, continuing a cycle of creation that has been repeating since the Milky Way was young. As young clusters push away the clouds that created them, they begin their long drift through the galaxy. Some remain tightly bound, traveling together like families that refuse to part. Others slowly unravel, their stars scattering across the spiral arms, until only a faint memory of their shared origin remains. These stellar nurseries, dark, cold, and full of potential, show that the Milky Way is constantly renewing itself. Every wave of creation gives rise to a new generation of suns, continuing cycles that have unfolded for billions of years. As some stars approach the final phases of their lives, their outer layers loosen and begin to drift away. What remains blooms outward into vast shells of glowing gas, gently expanding like luminous petals in space. The fading core at the center illuminates these structures, painting them in soft hues that ripple across the dark. These delicate formations, planetary nebulae, have nothing to do with planets, yet their shapes often resemble rings, wings, or perfectly rounded spheres. Their forms are sculpted by rotation, by magnetic fields, and by the subtle flow of material surrounding the dying star. Eventually, their gas disperses and joins the wider interstellar medium, becoming part of the raw ingredients for future stars and worlds. For a brief cosmic moment, a quiet ending becomes a spectacle of gentle color, a final gift from a star whose light is fading. Among the many hues that fill the Milky Way, there exist stars that glow with a deep, velvety red. These are carbon stars. Stars whose atmospheres are rich in carbon compounds that soften blue light and allow crimson tones to dominate. Such stars arise late in life, after heavy elements are dredged upward from their interiors. Their warm, red radiance is striking, especially when observed in infrared, where they shine with unusual clarity. They also create dust, fine particles that drift outward and enrich the galaxy with new material. Carbon stars remind us that chemistry can transform starlight as profoundly as mass or temperature. Even small changes inside a star can blossom into extraordinary beauty. Some planets in the Milky Way never witness a sunrise. Locked by gravity, they rotate in such a way that one side always faces their star, while the other remains in endless darkness. The perpetual day side grows blisteringly hot, scorched by unchanging light. The night side freezes beneath a sky where starlight never touches the ground, only the thin band between them. The twilight zone offers gentler temperatures, where winds carry warmth across the boundary between blazing day and frozen night. On worlds orbiting small, cool stars, these locked configurations are common. Despite their stark lighting, some may still hold liquid water if their atmospheres circulate heat effectively. Studying these planets expands our sense of what a habitable world can be. They show that day and night are not universal ideas, merely local habits of our own spinning Earth. In other places, light may never rise and never fall. High above and far below the galactic center, two immense shapes rise like gentle, ghostly lanterns, vast bubbles of energized particles lifting away from the Milky Way's core. They extend for thousands upon thousands of light years, so large that imagining their scale feels almost impossible. These structures, smooth and rounded, were sculpted by forces that once surged through the galactic heart, perhaps by ancient starbursts that erupted in fierce brilliance, or by past outflows from the central black hole when it fed more vigorously than it does today. Whatever their origin, they carry the quiet memory of a time when the galaxy's center pulsed with extraordinary energy. Inside these enormous lobes, charged particles spiral through invisible magnetic fields, creating faint radio murmurs that outline their shape like soft brushstrokes. Viewed from afar, the bubbles resemble enormous wings lifting from the galaxy's midplane, a sign that even long ago events can leave imprints across staggering distances. They remind us that the Milky Way, though calm to our eyes, has lived through epochs of drama whose echoes still glow in the faintest wavelengths of light. Hidden throughout the galaxy are pairs of black holes, silent twins locked in gravitational embrace. These duos begin as massive stars born together in shared clouds of gas. Each eventually collapses into a black hole, and together they orbit a common center of mass, drawing ever closer as they shed energy in the form of gravitational waves that ripple silently across space. Because black holes emit no light, their presence is discovered only through subtle signs. A nearby star tugged in an unexpected direction, a burst of high-energy radiation when one black hole steals matter from a passing companion, or tiny distortions in the timing of starlight revealing a hidden dance in the dark. Most of these systems remain quiet for eons, drifting invisibly through the Milky Way. But one day, each pair will spiral inward and collide, merging in a colossal event that releases a storm of gravitational energy far across the galaxy. Their existence adds a hushed tension to the Milky Way, a reminder that even in darkness, motion and destiny continue unfolding. Around many young stars, rings of dust glow with a soft warmth, like embers illuminated by distant fire. These disks are the first sketches of future worlds. Tiny grains collide and cling to each other, growing slowly into stones, then mountains of rock and ice, and eventually into planets. As newborn worlds carve paths through the dust, they leave behind delicate ripples, gaps, and swirling patterns, signatures of creation in progress. Infrared light reveals these structures where visible light cannot penetrate, showing halos of glowing dust that cradle the beginnings of entire solar systems. To witness one of these disks is to glimpse the opening chapter of countless worlds that have yet to take shape. Drifting far from any star are the galaxy's wandering giants, planets as large as or larger than Jupiter that roam endlessly through cold, interstellar night. They were likely born in crowded planetary systems, but strong gravitational encounters flung them into the darkness, setting them adrift with no sun to warm them. Without a parent star, they journey alone, lit only by the fading glow of their own internal heat. Some of these worlds still carry thick atmospheres that trap warmth in swirling layers. Others host slow, colossal storms that move silently across their frozen skies. Detecting these solitary giants requires watching for faint infrared glimmers or noticing the slight bending of starlight when one passes between Earth and a distant star. Their existence reveals how turbulent and unpredictable the birth of planetary systems can be. They show that planets are not always bound, some are set free, drifting through the galaxy with only their own gravity as company. In some binary systems, one star becomes so dense and compact that it begins to siphon material from its partner. This can occur when a star turns into a white dwarf, neutron star, or black hole. Its powerful gravitational pull draws gas from the outer layers of its companion, forming streams that spiral inward like threads of glowing silk. This cosmic feeding can trigger bursts of radiation, flashes of X-rays, or sudden brightening events as the captured material heats and swirls around the compact object. These parasitic systems reveal the dramatic relationships stars can form, relationships shaped by hunger, gravity, and the inevitable transformations of time. The stolen light of a star does not vanish quietly. When a compact companion begins drawing matter from its neighbor, the borrowed material forms a glowing whirlpool around it, a spiraling disk of gas that heats as it falls inward. Each turn of that spiral unlocks energy, and from time to time, the system erupts in sudden flashes that light up the sky like cosmic sparks. Across centuries and millennia, the devouring star may grow heavier, denser, and more unstable, slowly reshaped by the material it gathers. Its partner, meanwhile, is transformed as well, its outer layers stripped away, its structure altered, its future rewritten. These intimate stellar relationships remind us that stars are not always solitary wanderers. They can live intertwined lives, bound together by gravity, sharing matter, energy, and fate. In their interactions, cooperation and conflict are woven so tightly that one cannot exist without the other. Even light years away, the idea of two stars locked in such a delicate exchange feels surprisingly familiar, a quiet echo of how deeply connected cosmic objects can be. Some planets continue to orbit stars long after those stars have died. It seems impossible at first that a world could survive the collapse of its sun or remain steady while its parent star becomes a white dwarf, or even a neutron star. Yet in the Milky Way, such strange survivors exist. Some may have formed from the debris left behind after the star shed its outer layers. Others may have drifted back inward once the violence faded and the star's remnant settled into silence. Around a white dwarf, a planet can eventually receive steady, gentle warmth once the remnant cools. Around a neutron star, conditions become far stranger. Magnetic fields sweep and twist around the world, shaping an atmosphere in ways we can barely imagine. The presence of these planets reminds us that endings in the cosmos can give rise to new configurations, unexpected, resilient, and astonishing. Even the death of a star does not silence the possibility of worlds. Scattered across the Milky Way are regions enriched with organic molecules, complex structures built from simple atoms, forming quietly in the coldest corners of space. These molecules gather on the surfaces of dust grains, or arise within chilled clouds where ultraviolet light can scarcely reach. Some resemble the precursors of biochemistry, yet their existence alone does not imply life. Instead, they tell a gentler story: that the universe naturally assembles complexity, even in places untouched by warmth or sunlight. Infrared and radio telescopes reveal their faint signatures, showing just how abundant these structures are. They drift through the galaxy, eventually becoming part of comets, asteroids, or the building blocks of future planets. Knowing that organic chemistry thrives in quiet molecular clouds adds a sense of kinship with the wider universe. It suggests that the seeds of complexity are not rare, they are simply waiting for the right place to bloom. When a star dies in a supernova, its story does not end with the explosion. The shattered remains of its outer layers continue drifting through the Milky Way for millions of years. These fragments, still warm with the memory of the star's core, stretch into filaments and expanding clouds. Some pieces mixed into dense molecular regions, becoming part of the material that will someday form new suns and planets. Other fragments wander alone, cooling slowly as they move through the interstellar dark. By studying these drifting relics, astronomers trace the inner workings of ancient stars and learn how heavy elements, the same elements that build planets, oceans, and even living bodies, spread across the galaxy. In this quiet debris, we see the continuation of a cycle that has shaped the Milky Way for billions of years. Death feeding life, ashes becoming future light. The remnants of ancient supernovas drift quietly through the Milky Way, their fragments glowing in different wavelengths: soft radio murmurs, gentle infrared warmth, or sharp bursts of X-ray light. Each drifting cloud carries a signature etched by the temperature of its dust and the energy locked within its gases. Even after millions of years, these fragments remain visible to the patient eye of a telescope, serving as markers of enormous events that reshape the chemical soul of our galaxy. These remnants form a bridge across time. Debris birthed in violent explosions, now floating softly through quiet space, waiting to see the next generation of stars. With every slow drift, they carry forward the legacy of suns that lived brilliantly and died with unimaginable power. Somewhere in the Milky Way, a speeding star plows through a cloud of gas, and the meeting of motion and resistance creates a shimmering boundary, a bow-shaped wave not unlike the crest that forms in front of a boat. The star presses forward, and the gas gathers in a luminous arc ahead of it, glowing softly where compression heats the dust. The shape of that arc reveals secrets. How strong the star's winds blow, how dense the surrounding medium is, how quickly the star races through the void. Some bow shocks grow vast, stretching for light years like celestial sculptures carved from faint light. Following these arcs, astronomers trace the paths of runaway stars, objects flung from their birthplaces long ago, still announcing their motion through the curves they draw in the interstellar sea. Even the simple act of moving through gas becomes art on a cosmic scale. Among the stars of the Milky Way live a handful of luminous giants, short-lived, brilliant, and restless. These massive stars burn with such intensity that their entire lives unfold in the briefest span of cosmic time. In just a few million years, they consume their fuel, sculpt their surroundings with fierce ultraviolet radiation, and drive powerful winds that sweep through nearby clouds. They shape nebulae, carving space into pockets and hollows where new stars may arise or old ones may dissipate. And when their short life ends, they explode in spectacular supernovas, releasing heavy elements into the galaxy: iron, calcium, carbon, and countless more. The Milky Way owes much of its richness to stars that lived fast, burned hot, and left behind the ingredients for future worlds. Far away on distant planets, storms unfold on scales we cannot imagine. Some worlds experience tempests so vast they dwarf Earth entirely, immense spiraling structures that churn for decades, centuries, or perhaps never fully end. Thick atmospheres form bands of wind that collide and twist, creating colossal vortices tinted by the chemistry of their clouds. Amber, teal, crimson, each color speaks of temperatures and molecules that shape the storm's shifting face. By watching these worlds, astronomers learn what weather looks like under unfamiliar suns, in conditions far removed from our home. These roaring, swirling systems remind us how dynamic and unpredictable the cosmos can be, and how every planet becomes a canvas for forces greater than wind and rain. In some regions of the Milky Way, stars gather so tightly that the night sky from within such a cluster would shine with almost unbearable brilliance. A single light year may hold dozens of suns, their combined glow turning darkness into silver. These dense clusters are young, their stars born from the same giant cloud, still held together by gravity. Each star feels the nudge of its neighbors, its motion continually shaped by countless small interactions. Over time, some stars wander away, escaping into the broader galaxy. But the most tightly bound clusters persist, bright knots of starlight drifting together through the cosmic sea. They offer a window into the environments where many stars, including suns like our own, first ignite. Near the center of the galaxy, gas behaves in ways that seem almost dreamlike. Under the influence of powerful magnetic fields and the fierce radiation surrounding the supermassive black hole, clouds twist into long, luminous strands, delicate arcs that resemble ribbons unfurling in slow motion. These structures glow in radio and infrared light, tracing invisible magnetic pathways that weave through the galactic core. Some arcs form where streams of energetic particles collide with dense pockets of gas, creating thin, glowing filaments that shimmer in the dark. By following these gentle curves, astronomers map the hidden architecture of the Milky Way's heart, a place where gravity, magnetism, and energy entangle themselves into patterns we are only beginning to understand. The ribbon-like arcs near the galactic center may appear serene, but their stillness is only an illusion. Each curve tells a quiet story of motion, of gas swept forward by ancient winds, of magnetic fields gathering strength and twisting through space, of distant explosions whose echoes continue to shape the present. When astronomers trace these delicate structures, they uncover how material flows through the core of the Milky Way, how invisible forces bend gas into luminous threads, how energy pools and disperses, how the galaxy remembers every powerful event it has endured. Even here, in one of the most extreme environments imaginable, grace emerges from chaos, a reminder that beauty often grows from forces we cannot see. Across the Milky Way, there are stars that flare with sudden brilliance, erupting in bursts of radiation that spill outward like brief lightning storms across space. These outbursts come from deep beneath the surface, where tangled magnetic fields snap and reconnect, releasing energy far beyond the star's usual glow. Planets wandering too close to such a restless sun experience skies that brighten without warning. The air around them may heat sharply, their atmospheres shifting in chemistry with every pulse of radiation. Some planets slowly lose their upper layers, as each flare carries away a whisper of their fragile air. And yet, in their quiet resilience, many worlds endure, crafting atmospheric defenses, adapting to cycles of sudden light. Studying these volatile systems reveals how life and climate are shaped not only by steady sunlight but also by the unpredictable rhythm of a star's magnetic heartbeat. Scattered through the galaxy are even stranger sources of light, brief flashes of gamma radiation, the most energetic brilliance the universe can produce. These events last only seconds, but in that short window they release more energy than countless stars emit in a lifetime. Some are born from collisions between dense stellar remnants, others arise from magnetic fractures in compact stars where matter is squeezed into unimaginable states. Because these flashes appear without warning, astronomers must be watching at the precise moment they occur. But when we do catch one, even for the briefest instant, it becomes a window into realms of physics that cannot be replicated anywhere in the cosmos. These fleeting storms remind us that hidden within the Milky Way are events so powerful, so sudden, that the sky itself seems to inhale and exhale light. In certain quiet regions of the galaxy, stars are born not in clusters or scattered groups but in long, delicate chains, as though someone drew lines of starlight across the darkness. These stellar strands arise from filaments of gas that collapse along narrow paths. The filament tightens, then breaks into evenly spaced pockets that each give birth to a star. The arrangement creates a necklace of new suns, each glowing softly in the order written by gravity. As these stars ignite, their light touches the surrounding gas, carving small hollows and shaping the remnants of the filament. These beaded formations reveal how turbulence, pressure, and magnetic fields collaborate to turn simple threads of gas into elegant constellations of beginnings. Elsewhere, enormous clouds of dust and gas hide entire swaths of the galaxy from view. Through an ordinary telescope, they appear as empty dark patches, windows where starlight simply vanishes. But these voids are not empty, they are thick, cold reservoirs of molecular material dense enough to block every star behind them. Inside these shadowed sanctuaries, temperatures fall so low that complex molecules form on tiny grains of dust. In time, gravity gathers some regions of the cloud into knots, seeds of new suns waiting for the moment when their cores ignite. To our eyes, these clouds seem like absence, but through infrared and radio eyes, they reveal hidden cities of gas, corridors of forming stars, and dense pockets destined to shine in the future. These dark nebulae sculpt the Milky Way's appearance, carving long, quiet lanes through the bright band of night. They remind us that darkness in the cosmos is rarely empty. It is often the quiet beginning of something soon to be born. Some of the smallest stars in the galaxy hold the longest stories. Red dwarfs, faint, ember-like suns scattered throughout the Milky Way, burn so slowly and so gently that their lifetimes stretch far beyond anything we can imagine. Unlike massive stars that flare brightly and fade quickly, these quiet suns sip their hydrogen with remarkable efficiency. They glow with a steady, patient light, a warmth that can last for trillions of years, longer than the universe has even existed. A red dwarf born tonight may still shine when the Milky Way itself has transformed into something unrecognizable, when all the bright, short-lived stars have collapsed into remnants, and the galaxy drifts silently through a dimmer cosmic era. Because red dwarfs endure for so long, their planets are given vast stretches of time to change, to cool or warm, to reshape themselves through winds, oceans, and geological breath. Many of the most intriguing worlds orbit these slow-burning stars, basking in a calm, deep red glow that brings a different kind of daylight to their skies. Knowing that these tiny suns dominate our galaxy gives a sense of continuity, a reminder that the Milky Way's future belongs not to the giants, but to the smallest and quietest fires. Deep inside the densest curtains of dust, the galaxy hides entire factories of new stars. To ordinary eyes, these regions look like patches of darkness, lightless voids where even starlight seems to disappear. But beneath those shadows, a quiet kindling is taking place. Infrared eyes reveal clusters of newborn suns still wrapped in their cocoons of cold gas. Dust shields these fragile beginnings from the harsh radiation of nearby stars, allowing gravity to gather and shape new stellar hearts. Over time, their growing warmth hollows small chambers in the cloud, creating windows through which their light finally escapes. These hidden nurseries are among the most active corners of the Milky Way, continually building the stars that will someday drift across the spiral arms. Most of the galaxy's creativity happens behind these veils, soft, silent, and unseen. Sometimes, a star's life is changed in an instant. When two stars orbit closely and one ends its life in a brilliant supernova, the surviving companion may be hurled outward as though flung from a cosmic slingshot. Freed from its former orbit, the star races through the Milky Way at extraordinary speeds. Its motion becomes a record of violence, a testament to the sudden power released when a stellar core collapses. These runaway stars wander far from the places where they were born, carrying with them chemical fingerprints of their original homes. Tracking their lonely paths helps astronomers understand the complex dances and abrupt endings that shape binary systems. Each swift traveler is a reminder that even a quiet sky holds memories of explosions long faded into darkness. Not every planetary system is orderly. Some worlds circle their stars on sharply tilted paths, moving at steep angles that defy the flat, gentle plane we see in our own solar system. These wild orbits often arise from past encounters: a passing star, a giant planet wandering too close, or a distant companion pulling subtly over millions of years. Such interactions twist the architecture of a system, leaving planets to sweep through space on orbits that lean dramatically against the stellar equator. On these worlds, seasons may be extreme, sunlight arriving from unusual angles, daylight stretching unpredictably across the sky. Yet this very case tells astronomers how dynamic and surprising planetary evolution can be. The Milky Way is filled with systems that grew in ways unlike our own, strange arrangements shaped by ancient gravitational conversations. And then there are the worlds where warmth never truly comes. In the far, dim regions of the galaxy, or around stars that glow with only the faintest light, some planets remain locked in frozen stillness. Their surfaces are sealed beneath kilometers of ice, unchanged for eons. Some of these frozen worlds orbit faint red suns, others drift freely through space with no star at all, cooling slowly until the last of their internal heat fades. On the surface, everything appears silent, a permanent winter without sunrise. Yet deep below the ice, there may be slow and hidden activity. Rocks shifting under pressure, chemistry unfolding in darkness, oceans preserved beneath the frozen shell. These worlds remind us that even in the coldest corners of the galaxy, stillness can hold mysteries and silence can harbor stories waiting to be told. Frozen worlds drift through the Milky Way like silent sculptures of cosmic time. Their icy crusts barely change from century to century, locking away whatever lies beneath in stillness so deep it feels almost eternal. Studying these frozen planets helps astronomers understand how worlds gradually lose their heat, how atmospheres thin, and how geology slows until even mountains seem frozen in place. Compared to warmer planets where storms rage and surfaces shift, these quiet spheres are reminders that some environments in the galaxy are ruled entirely by cold, places where winter is not a season, but a permanent state of being. Elsewhere in the galaxy, clouds of charged gas glow with a faint, eerie radiance. These electrically charged nebulae shimmer not because of reflected starlight, but because energy strips electrons from atoms and sets them drifting through magnetic fields. As they recombine or spiral through invisible structures, they release soft, ghost-like glows detectable only in special wavelengths. These nebulae often form near hot, energetic stars or in regions scarred by ancient explosions. Their presence marks areas where powerful forces have shaken, heated, or reshaped the gas. By observing their glow, astronomers uncover the hidden magnetic threads woven through space, the temperature of the gas, and the sources of the energy that stirs it. Even though their light is faint, these nebulae add a quiet, unearthly beauty to the Milky Way, a reminder that even the dimmest regions carry stories written in delicate traces of energy. Some stars do not emerge alone or even in pairs, but in groups of three bound together by gravity in delicate, interwoven orbits. Inside dense birth clouds, several fragments may collapse at nearly the same moment, forming triple systems whose dances can persist for millions or even billions of years. Often two stars orbit closely, tracing tight loops around one another, while a third circles farther out. In other arrangements, all three move on elongated, braided paths around a shared center of gravity. These graceful configurations reveal how complex stellar formation can be, how gravity sculpts relationships far more intricate than simple solitary suns. Over time, some triple systems remain stable, while others slowly unravel. A star may drift away into the galaxy, leaving the remaining pair behind. Studying these trios helps astronomers understand how stars influence each other from the moment they are born and how their early interactions shape any planets that try to form around them. There are worlds whose orbits are so stretched that a single year carries them from bitter cold to blistering heat. When these planets drift far from their stars, their atmospheres may freeze into crystals and frost, forming layers of ice that coat their skies. But as they swing back inward, temperatures surge and everything melts. Clouds expand, surfaces warm, and entire climates transform in a matter of weeks. These cycles of freezing and boiling create worlds that never settle, planets where nothing stays the same for long. Their unusual paths are often the result of past gravitational encounters, near misses with other planets, or the influence of a distant companion star that twists their orbit into an elongated ellipse. By watching these extreme worlds, scientists learn how profoundly the shape of an orbit can influence a planet's environment and the chances for any stability to emerge. Across the Milky Way are gas clouds warmed by radiation from sources so distant they seem unrelated at first glance. These clouds glow with temperatures higher than their surroundings, yet no young stars or recent supernovas lie nearby. Instead, their heat comes from high-energy photons that have traveled immense distances before finally striking the gas and sharing their energy. These photons may originate from ancient explosions, energetic regions near the galactic center, or compact stars that release powerful radiation. By tracing these warmed areas, astronomers map the invisible flow of energy that weaves quietly across the galaxy. These softly heated clouds reveal that space is rarely still. Light from distant events continues to ripple outward, leaving behind faint signatures in regions that otherwise appear dark and calm. Some planets in the Milky Way are shaped not by their own gravity alone, but by the relentless pull of nearby giants. When a world orbits extremely close to its star, or shares space with a massive companion, the unequal tug on its near and far sides stretches it subtly out of round. Over time, these worlds can take on shapes slightly elongated, almost like softened teardrops drifting through space. This distortion doesn't remain only on the surface. The internal layers flex and shift with every orbit, creating heat from friction deep within the crust. That warmth can ignite volcanic activity, reshape landscapes, or alter the circulation of the atmosphere. On some worlds, the same side forever faces the star, while the elongated shape exaggerates the temperature divide between the burning day side and the cold, shadowed hemisphere. Such planets reveal how powerful gravity can be, capable of sculpting entire worlds into forms that challenge the simple idea of planets as perfect spheres. Scattered across the Milky Way are quiet pockets of primordial hydrogen, gas that has drifted through the galaxy since near the dawn of time. While most of the hydrogen in the Milky Way has been enriched by generations of stars forging heavier elements, these ancient clouds remain remarkably unchanged. They carry a simpler chemistry, preserving conditions that existed before the galaxy's spiral arms fully formed. Cold, faint, and difficult to detect, these clouds nevertheless play an essential role. They act as reservoirs, slowly feeding future star-forming regions and allowing astronomers to compare the modern galaxy to its earliest chapters. Primordial hydrogen drifts like a whisper from the universe's youth, a reminder that the galaxy carries echoes of creation within its vast and quiet spaces. Not all massive stars end their lives in brilliant explosions. Some slip into darkness in a far quieter way. When internal pressures fail suddenly, the star's core collapses so quickly that no outward blast is launched into space. Instead, the outer layers fall inward, forming a neutron star or black hole with barely a flicker to mark the transformation. These silent endings are elusive. Astronomers search for stars that simply vanish, or for subtle gravitational signatures hinting that a compact remnant now exists where a shining star once stood. These quiet collapses broaden our understanding of how stars die, revealing that the line between explosive and silent endings depends on delicate balances of mass, structure, and rotation. Some planets are born in places far more chaotic than the gentle environment that shaped our own solar system. Within clusters of 3 or more stars, gravity shifts constantly, pulling and twisting the dusty disks from which planets emerge. Young worlds must navigate these competing forces, searching for stable paths amid the disorder. Some planets succeed, settling into orbits around one star. Others circle pairs of stars together, their skies filled with multiple suns. A few travel wide loops around the entire group. But many are not so lucky. Destabilized by the shifting pulls, they are cast out into space as lonely roaming planets. These complex environments show that planetary formation is not limited to calm, orderly systems. Even in regions filled with gravitational conflict, worlds can arise, adapt, and survive. Near the center of the Milky Way, where gravity tightens and radiation grows intense, swirling disks of hot dust circle the central black hole. These disks glow brightly in infrared light, each grain of dust heated by the surrounding energy. The material spirals inward along fast, curving paths guided by magnetic fields and the pull of the immense mass at the core. As the dust flows, it interacts with surrounding gas and creates structures that shift and ripple over time. Astronomers watch these disks to understand how material moves toward the black hole, how energy flows outward, and how the heart of the galaxy shapes everything around it. These glowing spirals serve as reminders that even in regions dominated by gravity and darkness, motion and light continue to coexist, quietly shaping the Milky Way from its very center. The glowing spirals near the galactic center whisper a truth that is easy to miss. Even the smallest grains of dust can move with astonishing grace when they fall under the influence of the core's immense gravity. There, dust doesn't simply drift. It unfurls into luminous ribbons, curling and folding as if responding to unseen currents in space. These delicate shapes reveal just how alive the galactic heart is, a place where even silence is filled with motion. Throughout the Milky Way lie slender structures that resemble cosmic threads. These long, cool filaments, sometimes stretching for dozens of light years, hold gas so cold and dense that it quietly edges toward collapse. Along these narrow pathways, gravity gathers the material into beads of increasing mass. Each bead becomes a cradle, a place where a young star begins to kindle. These filaments act almost like the backbone of a molecular cloud, guiding material along their length and orchestrating where new stars will emerge. From afar, they bring a gentle order to what first looks like chaos, revealing that star formation often follows the subtle architecture of space itself, a quiet choreography written in threads of gas and dust. Not all stars are born into bustling neighborhoods. Some wander so far from others that they spend their entire lifetimes in near-perfect solitude. These isolated suns drift through calm, open regions of the galaxy where little disturbs their slow evolution. They do not face the radiation of massive neighbors or the gravitational nudges of passing stars. If such a star possesses planets, those worlds may experience a rare stability, a cosmic stillness in which change comes only from within. These solitary travelers trace gentle arcs around the Milky Way, living out their long eras without ever joining a cluster or crowd. They remind us that loneliness exists even among the stars, and that some lights journey from birth to death with no companions but their own steady glow. Elsewhere in the galaxy, ancient stellar relics drift quietly through space. These stars formed so early in cosmic history that their atmospheres preserve the original chemistry of the universe. Hydrogen and helium dominate their makeup, with only the faintest traces of heavier elements, a signature of a time before stars had seeded the galaxy with the ingredients for planets, life, and complexity. Their light is dim, yet immeasurably valuable. It carries clues about the earliest eras of star formation, revealing what the Milky Way looked like when it was still assembling itself from raw cosmic material. Many of these ancient stars reside in the halo, where sparse gas and gentle conditions have allowed them to remain unchanged for billions of years. They are time capsules, quiet beacons that bridge the present galaxy to its nearly primordial past. Some planets orbit stars that sit precariously on the edge of stability. These volatile suns burn through their fuel unevenly, sometimes swelling outward, sometimes pulsing or dimming in unpredictable cycles. Their inner layers shift like restless tides, creating rapid changes in temperature and brightness. Planets bound to such stars live under skies that can transform without warning. A sudden burst of radiation may alter their atmospheres, while long, slow changes in stellar size can reshape the climate over centuries or millennia. These worlds experience a kind of cosmic weather far more dramatic than anything known around stable stars like our Sun. Such systems show how fragile planetary environments can be when the light that sustains them is itself unsteady, a reminder that not all stars offer calm, reliable warmth. Some flicker, swell, and breathe through deep cycles that shape every world within their reach. As some stars drift through phases of instability, the worlds around them experience climates that shift like tides, sometimes slowly, sometimes with startling suddenness. A star that brightens or dims unpredictably casts evolving seasons onto any planet that depends on its glow. Studying such systems shows astronomers how worlds respond to a light source that cannot make up its mind. These fragile suns reveal just how narrow the path to long-term stability truly is. Some stars balance on the edge of order, their energy output flickering like a restless flame. The planets that orbit them live in ever-changing climates, shaped not by their own atmospheres, but by the temper of the star that warms them. They remind us that calm sunlight, the kind we take for granted, is not a universal gift. Across the Milky Way, gravity and radiation work together like sculptors carving stone. In many stellar nurseries, gigantic clouds of gas and dust rise into towering shapes, pillars that stretch upward like ancient monuments. These forms take shape as nearby massive stars blast the surrounding material with floods of energy. The softest portions of the cloud evaporate into space, but the densest knots endure, standing tall against the storm. Within these pillars, gravity tugs gently at the cold gas, gathering it inward until new stars spark to life in their sheltered depths. As time passes, light erodes the edges, stretching the structures, twisting them, or breaking them into fragments that drift away. Each pillar reveals the silent struggle between destruction and creation, and how, in the galaxy, the two are always intertwined. These sculpted columns are not static relics. They are dynamic works of cosmic art, shaped by winds, illuminated by new suns, and constantly rewritten by the forces that surround them. Scattered across the Milky Way are stars whose atmospheres defy expectation. Instead of the familiar blend of hydrogen and helium, their light reveals strong imprints of rare elements, carbon woven into deep layers, strontium shimmering in their outer shells, or even heavy atoms forged in ancient, violent collisions between compact stellar remnants. Some of these unusual stars were born from material enriched by cataclysms older than Earth itself. Others gained their exotic chemistry when a companion star transferred material onto them, altering their outer layers and rewriting their spectral signatures. Their light carries the fingerprints of remarkable histories, stories of stellar mergers, violent enrichments, and internal mixing that dredges rare material from deep within. To study these rare stars is to trace the pathways of heavy elements, as they spread across the Milky Way. Their spectra act like quiet messages from the past, revealing events that shaped the galaxy long before our sun ever formed. They are gentle reminders that the diversity of stars is far greater than it first appears, and that the Milky Way is filled with chemical stories still waiting to be understood. Some stars carry atmospheres shaped by rare processes, their surfaces glowing with colors born from elements that seldom appear elsewhere in the galaxy. These unusual compositions whisper of ancient collisions, of deep internal mixing, of quiet exchanges between companions long faded. Their starlight carries the memory of uncommon cosmic chemistry, a reminder that even among billions of suns, some shine with truly singular signatures. And there are worlds whose rings stretch so wide they could swallow the orbit of Earth. Great arcs of ice and dust sweep around them in pale, shimmering halos that glow gently in reflected starlight. These enormous rings form as young planets gather material, or as fragments of shattered moons drift into orbit. Guided by gravity, shaped by faint winds of radiation, they broaden into delicate, majestic structures that encircle their worlds like floating galaxies of their own. Their scale reveals how dramatic the early chapters of a planetary system can be, full of impacts, fractures, and quiet reassembly. Throughout the Milky Way, stellar remnants drift like elderly travelers moving at their own slow pace through the dark. White dwarfs cooling into silence, neutron stars spinning with fading strength, black holes passing unnoticed except for the way they tug softly on anything that wanders too near. These remnants are the last breaths of long-finished lives, still journeying, still shaping space in subtle ways. They remind us that the galaxy is not only built of youth and brightness, but also of quiet endurance. Some newborn systems begin overcrowded, multiple giant planets packed tightly beside one another. Early on, these giants push and pull, trading orbits, nudging siblings outward, sometimes flinging one into the frozen dark between the stars. In time, the chaos may settle, or it may continue for ages. These crowded beginnings show that solar systems do not always form in gentle, orderly rings. Sometimes they arise like bustling neighborhoods, full of motion and negotiation. Across the galaxy, magnetic fields occasionally snap with sudden, startling force. When they do, arcs of energized gas light up the darkness, brief, luminous marks of invisible tension being released. These magnetic whiplashes accelerate particles, send waves of radiation sweeping outward, and carve shapes into nearby clouds. They reveal the hidden engines that stir the Milky Way beneath its calm exterior. Some stars shed narrow jets that stretch for light years, thin streams of material flung outward by swirling magnetic force as gas spirals onto the young star's surface. Each jet pierces the surrounding medium, lighting up knots and ripples that drift slowly as time unfolds. They show how even a small star, still learning to shine, can reach astonishing distances. Not every world is born in warmth. Some take shape in deep shadows far from any nourishing light. Their skies remain dim, their surfaces cold, their atmospheres developing slowly in faint, distant glow. These worlds remind us that creation does not require brightness, only time, gravity, and a quiet corner of a spinning disk of dust. Thank you for spending this gentle stretch of time beneath the slow, drifting river of the Milky Way. You don't have to hold on to any of these thoughts. Let them settle wherever they wish, somewhere soft, somewhere quiet, somewhere deep inside the stillness that gathers as night unfolds. The galaxy will remain exactly where it is, patient and unhurried, glowing faintly behind closed eyes like a memory you don't need to chase. If these calm wanderings brought you even a moment of peace, you're welcome to like, subscribe, or leave a sleepy word below. It helps others find their way here, one tired mind at a time. And now just imagine the slow drift of distant stars, the hush that fills the spaces between them, the gentle weightlessness that stretches across thousands of light years. Let that feeling rise around you and soften everything inside. You do not have to reach for sleep. It will come on its own, quietly, naturally, like night settling over an open sky. If your thoughts are still awake, another soft journey will be waiting whenever you want it. And if your eyes are already growing heavy, you can let them close and let yourself drift into rest. Good night. Sleep deeply. You're safe here.